things on this webinar. It's been a little while since we've done one of these. So if this is your first time, welcome. If you've joined other webinars, thanks for joining again. As you guys saw in the email that you guys received from us to register this or saw on the website, we do record these and then we put them on our YouTube channel. So if you guys look up and go on YouTube and look up ATI Metrology Training Channel, it'll pop up. You can subscribe to it. I've started doing little short videos on there of just little, tips and tricks like we cover in these webinars, just so you guys can go back and reference, little 1-minute videos on how to do certain things. We are always open up for suggestions of, hey, it'd be nice to have a video to go back to kind of remember that or do this or something like that. I've been thinking about doing short little 5-minute videos on each GD&T symbol that the MicroView can measure. But we'll see when I can get those out. And then keep your eyes open because this year there's going to be some exciting things launching with MicroView. So always cue into that. And we'll talk about those on this webinar from time to time throughout the year. A little more housekeeping I just want to go through before we get through some of the topics that I want to cover today. We offer training courses at our Elgin facility, which I'm at right now, our Warsaw, Indiana facility, and also we bring it throughout the Midwest training seminars. So last week I was up in beautiful Eau Claire, Wisconsin, which I saw a couple of you from up in the Chippewa Falls Valley area. You guys logged in today. I was up there and we got hit by a 10-inch snowstorm Wednesday night, which was fun. But yeah, we bring these training seminars, everything from GD&T fundamentals. So learn like the how, why, and what all these different symbols are per the ASME 2018 standard. We also cover some of the ISO standard in that as well, but it's a 2-day course. It teaches you, what GD&T is, why to use GD&T when you're designing a part, engineering a part, and then also how do we measure it, especially if we don't have a CMM or if the MicroView is tied up with something else, how can we measure it with hand gauges, height gauges, and so on. Then we also have hand gauge usage 101 and blueprint reading 101. Great for review if you've been around the manufacturing industry for a while, or perfect for brand new employees on your team. Get them the nice foundation of how to use hand gauges like calipers, micrometers, and how to read a basic blueprint. Then we have MicroView Level 1 and Level 2. If you've been one of our customers for a long time, we used to have MicroView Basic training and MicroView Advanced training. We've kind of reformatted that. So instead of a 4-hour basic course, we're going to do a 6 to 7 hour Level 1 course that incorporates some of the advanced manual stuff that really wasn't advanced, but it's stuff you need to know for like that Level 1 programmer level. And then that allows us to go into Level 2 that is some really advanced stuff that doesn't even get covered in the advanced course that you've taken in the past. So if you have any questions about those, like what topics you've already had training on and what's new to those, shoot me an email. You can either email Dustin at atiquality.com or training. And if any of you guys have the CMM Manager software, we also offer courses on that. So here's just some calendars. This is February, by the way. So we'll be down in Warsaw in about a week and a half. And then we have a GD&T fundamentals scheduled for Elgin and GD&T fundamentals scheduled for Warsaw. And then March, we have a bunch of stuff coming up. So you can always go to the events page on our website and you can see when the next class is going to come up for that. Also, just to let you guys know, we have a bunch of services we offer. MicroView programming, CMM programming. If you guys are having difficulties with any inspections, or if you guys are overloaded in work, or parts are too big for your machines, you can send it to us at ATI and email Metrology at atiquality.com for any of those type of things. But let's get into the webinar because that's what you guys are here for today, right? So things I want to talk about today: stitch snapshots. If you've had training with me, Dan, or any of the other trainers for the past however many years, we've always kind of said you can't stitch snapshots in MicroView because we actually didn't know about this feature. It takes a couple tips or tricks to get to this, but we can actually save a stitch snapshot of your whole part using a MicroView, which is really cool. I actually learned it from some of our friends up in Wisconsin. So anytime that I'm on site training with you guys, I'm learning something new too. So we'll talk about that. Talk about exporting those snapshots to a folder. A couple different options there. I've talked about these two next things in previous webinars before, but I want to really like drive them home today. Setting multiple systems. Customer emailed me yesterday or the day before, and they have 400 parts they need to run with a semi-automated program. So they want to get that program up and running as fast as possible. And instead of doing your datums as your first system, we can do just a real simple system. We can set as many systems as we want on a part for ease of semi-automated programs, even automated programs. So I just want to drive that home today. And then looking for a feature at a certain Z height. Once we set up that datum, it's easy to move around our part at different Z heights with this little trick that I use. And then, I don't know if anybody's read this so far. I don't mean to stress you out on a Saturday. I wish it was Saturday, right? Friday morning. Have you guys ever seen profile, parallelism, and flatness on one feature before? Yeah, it's a fun thing. It's actually really useful, but I can imagine if you're not used to GD&T and you see three stacked on top of each other, it could be a little intimidating right there. So I want to talk about that a little bit and get a lot of requests to talk more and more about GD&T on these webinars. So why not start off the new year of 2023 with throwing three different GD&T tolerances on one feature, and we can work through it on the MicroView here. So first thing I want to talk about is let's talk about stitching snapshots. So I'm gonna come over here. I got my MicroView software. I'm gonna use the stage controls to move around today. I'm gonna come over and find this part. I'm gonna turn on my surface light here. I want to find this part. So customers have asked in the past, like, hey, I know we can right click in the camera window and save a snapshot, but it only gives us the option to save a snapshot of what the camera can see. So I'm bringing my camera up in Z right now so we can find this little sample right here. In the past, we've always just say we want to take a picture of this feature because we got this little cutout right here that's not supposed to be there. We want to, report to production or report to quality managers, say, hey, this is what I found. So we can right click in the camera window and save the snapshot. But that is only going to save what the camera can see. So in all the demos I've been a part of, and all the trainings I've been a part of, question always comes up, hey, can I take a picture of my whole part and export that? I always thought the answer was no until recently found out this trick. So what we're going to do is we always want to start from the upper left-hand corner and go down to the lower right-hand corner of our part. If you go right to left or, right to left, it's going to flip your JPEG. So if you want that, if the part's upside down on your stage and you want to take a picture from bottom right to upper left, and have the JPEG saved where it's the right side that you want, you could do that. But if we want to go ahead and take a picture of this whole feature and we want one whole stitch snapshot of it, what we're going to do is we're going to come up here and we're going to go to Feature, Insert, and go to OCR Text. So OCR text and OCR barcode are used to read text on a part, barcode on a part. And when we use the OCR text, you can actually click a box around some text and it can read that text. Being completely transparent with you guys, there's a lot of times that it doesn't do that great of a job of reading it, especially on turned parts, reading the different characteristics on there. Sometimes you have success depending on how much contrast you have in the letters or numbers. You're able to read that. But one trick that I found with this is if we go to OCR text, the way that we use it is you click in your camera window, top left corner, wherever you want to start the picture. You click and release your left mouse button, and this box shows up. So then we can start coming down and drag down to where we want the picture to stop. Now, one thing I'm going to warn you is that the larger picture you take, the longer it's going to take to compute and actually get that stitch snapshot. So if you have a very large part and an off-the-shelf, basic RAM type of computer, it might take a little bit to process it. But so I click again here, and so now that box is created to take that picture. And then if you guys can see, there's a little play button right here in the camera window. We go ahead and click that play button, and we see the microview go and scan throughout that box. And now you're going to see my little thinking hourglass there for a little bit. So this is going to take a couple of seconds to process. One time I tried to take a picture of the whole Excel stage, and I just had to cancel out of it. So there we go, we're done there. So we see that the tool goes green. So now when we right click in the camera window, we have a save stitch snapshot. So we can go ahead and save that snapshot. And I'm going to save it as a JPEG. If you wanted to show the tool or show the scale or feature name, like if you renamed it, you could. But I'm going to go ahead and click save. And now if we come to our file explorer and we open up that picture, it's a whole stitch snapshot of what we did in that OCR text box. So this could be useful if you want to take a picture of your whole part. This picture is scaled 1:1. So if you have any other softwares that can actually measure off a picture, you'd able to, store this and save it for later, and maybe down the road be able to bring that back in. I personally haven't done it, but I know some other softwares out there have the capability of measuring off of this picture. But so we have a stitch snapshot right there. So it's pretty useful if you want to take a picture of your whole part. In previous webinars, I've talked about how big this camera window is. And this camera window is about 12 millimeters wide on a Generation 3 machine. You're looking at about 9 or 10 millimeters wide on a Generation 2 or 1 machine. And then we're looking at about 8 to 10 millimeters high on this. So if you can't fit the part in your camera window and you want to save a snapshot of the whole thing, you're good to go there. Using the feature, insert, OCR text, click and drag, or not click and drag, click, release with your left button, move your camera down to where you want to end the picture, click again, and then hit that little play button. It'll scan, and then you can save that snapshot. Now, on the topic of snapshots, we can save, we can automatically export the snapshot. So if you want your program to end with it taking a picture of the whole part, we can do the OCR text. And then if we right click on our feature, and this works ready feature, we'll do a diameter here in a minute. You can go to exports, or you can hit F4 if you like your hotkeys. Down here, we have this option to export snapshots. We could do it if feature is out of tolerance, if it fails to measure, if it's within tolerance, or always. So I would use always in a situation where I'm using OCR text just to scan the whole part and export that picture so I can have record of it somewhere on my server. But now if we wanted to do something like a diameter, so I'm going to go over here and find another part of mine. Bring the Z-axis down. So I got this part here. I'm going to right click in the camera window, say move here. Wherever you right click in the camera window, you could say move here, so you could move the crosshairs over there. I'm going to hit the autofocus button. right click, move here to get the whole thing in the camera window. Now I'm going to do circle, F-scan circle, with my 3 points. I'm going to expand my guard band, but actually here's a little thing. Since we have some garbage going on the inside here, I'm going to flip my arrows to scan from the black to the edge of the part. If you've never noticed those red arrows before, you can search on our YouTube channel. I talk about those in a previous webinar. But if I right click on the circle and go to exports, this is where something that might be useful if you want to store a picture every time that the feature is out of tolerance. So we don't want to store a picture of every single diameter, like this specific feature. We don't want to store it every single time it measures it. We might want to just store proof or evidence, or just see what the diameter is after we run the part, and just have that in a file. So we can always hit F4 or right click tolerances, or right click exports, and then come down here to this drop down menu right here, and if the feature's out of tolerance, it'll export that picture. We also have one more step we got to do, that if we come up to tools, playback options, we need to come to this export snapshot tab, and we need to pick an option where to go. So we would come into here and say we want to go to the desktop, or on your server you can make a new folder, so you can have a dedicated folder for every JPEG that you export. Now this isn't a global change, this is per program. So every part number that you could have a dedicated folder to store those pictures, and they're all time-stamped on the JPEG. So when you export it and you ran them at 10 o'clock on Friday morning, then you know which parts are the ones that you're looking at for the file type there. Awesome. So just to review that part, if we go to feature, insert, OCR text, I can move over here, click once, release my left click, move down to the lower right hand corner, click again, and we hit this little play button. It'll scan, taking little JPEGs. It's going to take a little second to think. Maybe more than a couple seconds. This is where you can go and refill your coffee. And then once it goes green, we can right click, save stitch snapshot, and we're able to have a JPEG of that complete stored gasket. More than that. So hopefully that's useful for you guys. If not, just put it in your toolbox. Remember the options there. So if anything ever comes up, you're like, oh wait, I'm able to do that. I can save stitch snapshots. Awesome, you have the capability there. Let's talk about setting multiple systems. So I'm going to come down to this part over here. I'll try to show you as much of it on my camera window as I can. Let's turn on the surface lights. Let's get it in focus for you. We got this part here, bunch of geometry, some different ribs on it, different diameters, different Z heights, a little chamfer going on there, corner. Try not to go too fast for you guys. So we got this part here, part of, I believe it's part of some sort of filtration system in the medical industry. But if we have this part here and we don't have a fixture, we just have the option of writing a semi-automated program for this. I want to get this program up and running as quick as possible. Like I said earlier, I have a customer up in Wisconsin that they have to run 400 parts for this study, and it's going to be a semi-automated program. So they don't want to spend as much, they want to spend as least amount of time getting the part program up and running as possible. So a couple options that I lean towards is I'll go diameter line, or I'll do line intersection point. Whenever we do a system, you always should have an origin X and Y, which is going to be some sort of point. It could be an intersection point, it could be a center point of a diameter. Origin X and Y almost all the time is going to be a point. Origin of Z is always going to be a focus point or a plane. And then skew is always going to be a line. It could be a physical line on the edge of the part, or it could be a line between two diameters. Whatever you can create a line to centers of two radii, whatever might work right there. So I want to get this program up and running as quick as possible. I will look at my print and see, okay, what can I fit within the camera window so I don't even need to move the camera window to anything. I can just take everything all in one snapshot. So I'm going to turn on my profile light. I'm going to right click on this edge. Get that in focus. So if we look here, I have a straight edge and a radius, or I even have a straight edge and a diameter. But this diameter is out of focus because it's at a different Z height than my edge. So I'm going to have to move my Z up to get those two features. So that's still wasting time in the beginning of my program to get this program up and running. So I'm going to do a line and an arc just to locate really simply where my part is. And then I'm going to do a better system to really lock in where my part is on the stage. So I'm going to do line, F-scan line. And I'm going to do an arc with an F-scan arc down here. And remember, we got to make sure that these fit in the camera window. Every tool that we use needs to fit in the camera window. So I'm going to do origin. Yes, I'm going to do origin X, Y, and Z. And I'm going to do a skew to my edge. Now, since in my program, if you guys, as soon as you have a system in your features list, everything from here on out is going to be automated. So everything that we measure from here on out, the program's going to do by itself. So now we need to set a better system. So I'm going to do, side note, I said this earlier, if you have datums on your blueprint, datums or datums, depending where you're from, if you have them on your blueprint, your system needs to be your datums. If you have any GD&T on your blueprint or any specific coordinates, your datums need to be your system. Your system needs to be your datum. So if I was going to have this, I still don't have an origin of Z. So to make sure that I have the right Z height, I'm going to do a quick focus point on this surface. I'm at a low magnification. Every magnification costs you time in your programming. It'll take you about 5 seconds to go from your high mag or your low mag all the way down to your high magnification right here. So to save time, because I haven't done my true datum system yet, I'm just going to do a low mag Z point right there just to establish an origin of Z. So I'm going to set origin. I'm only going to have Z selected. Throw that on my focus point right there. And now I'm going to keep rolling with my better system. So now this diameter is datum B on my blueprint. I'm going to measure that. I'm going to rename this one datum B. If you don't know about the tags feature, if you click on a feature and you hit the tag, whatever you rename it, it'll pop up. No, you can't move where that little tag goes. It has a little mind of its own. Now I'm going to measure this other diameter. This is datum C. And now I'm going to do another system just because if this little radius moves a lot, this is going to be a better skew that I have. And this little line isn't that good of a skew, but that's just going to locate my part. And we should be able to hit these two diameters to really lock in a system. So I'm going to set my origin of X and Y to datum B, origin of Z to my focus point, and I'm going to skew. I'm going to click these two diameters, and there's an invisible line going between those two centers that create my skew, to create my alignment. But I'm still missing a solid system with a plane. Now my plane is going to be datum A. If datum A is the bottom of the part and my part's sitting on the glass, you could use some dry erase markers to establish the glass. In one of the previous webinars that we've done, we've talked about storing features, so I can recall my microview glass. So you can measure your glass once, store it as a feature, and then we can recall the microview glass whenever we need. I'm going to do my system on top of this part right here. So I'm going to do plane, focus point. Any datum that we do, we should have more than the minimum geometry points required for that datum. So when I click 3 points, that establishes a plane, but I want more than the minimum. So I'm going to come down here. I'm going to take at least a 4th point. I probably would want to take 5 or 6, but we're going to do that. We're at a low magnification because it's easier to find the part. Here's another little bonus trick that's on one of our other webinars. I did everything at a low magnification. Now I'm going to zoom in. I'm going to update my tool. I'm going to right click on that plane and I'm going to say set lights and zoom. Right clicking and saying set lights and zoom, whatever my current lights and zoom is and magnification, it's going to apply it to all those features. So now when I remeasure this, they're all at that 61x instead of that 22 that I was at. So it's easier to find where I'm moving, and then we can set lights and zoom. So now we got datum A established. I'm going to level to datum A. I'm going to set my origin X and Y to datum B. I'm going to set my origin of Z to datum A, and I'm going to skew between B and C. So now we have my system made up of datum A, B, and C. So now we know that any GD&T that we do here from here on out is all looking at datum A, B, and C, which we would see in a feature control frame. That if you see anything like this, you guys get to experience some of my amazing paint skills here. If we have a feature control frame and say we have true position with a diameter tolerance zone, let's say 5 thou. After that, it'll say what datums it references. So if we see this feature control frame, and we have to measure a diameter of, let's say, 100 thou, you know, this is looking at some feature. We know that, okay, true position, we have a position call out to A, B, and C. So when we come measure a diameter, should be one over here somewhere. When I measure this diameter here, I know my parent system is datum A, B, and C. So this feature is referencing my datum structure. So now I'm 100% sure that when I tolerance true position, when I tolerance whatever it might be, I know I'm looking at the right datum structure there. So multiple systems. We have one that really doesn't matter. All it's doing is getting our program up and running. This is, you know, I won't even rename this one because it's, you know, you call it beginning system. This one is built only of the Z origin. So we'll do X and Y to the center point of this arc, skew to that. And now this is set in my origin as Z. And then once we measure datum B and C, now we have this new system that is made up of datum B and C as our origin and our skew. And then we're still using that focus point just as a Z reference. Then we're able to establish a nice plane and actually set up our full datum structure as our system. Everything we have is needed. Everything that's needed, we have in our inputs. We're good to go and move on with the rest of our programming process there. So you can have as many systems as you want. Some parts, the worst, I shouldn't say it that way, but the worst blueprint I've ever seen had double letter datums on it. So I probably had 40 or 50 systems in my program because it was referencing over 40 datums on the print. It was a lot to wrap my head around, but you're able to have as many datums as you want, as many systems as you want in your program. If you guys ever have an application where you're like, hey, I have this part, here's the blueprint, what would you do to set up your system and get your program running as fast as possible? Shoot me an email. Myself or Dan are more than happy to, draw on the blueprint in Paint and kind of show you what we would do and get you on your way. We're more than happy to help you with that. I see Rick, he said, I label the final system as origin for ease of use, but ABC is good too. Yeah, if you don't have datums, that's another way to do it too. You could just say origin, label the system. I mean, it's really up to you. I was saying this in class yesterday. We had Microview level 1 training here in Elgin. I've been programming Microviews for about 10 years. I have my ways that I found are efficient for the way that I program, the way that my mind works. But what I tell you guys to do, if you guys find a better way or easier way or faster way, one, please email me and tell me, because I hate inefficiencies. So if there's a faster way to do it, I'd love to know. But also, if you find a better way, run with it. Whatever works for you and your parts. I mean, I see everything from plastic red cups to spaceship parts to hip replacements. So I'm kind of wide range of everything, but I haven't seen every single part either. There's a lot of parts that you guys send me that I'm like, okay, let's figure this one out. But to keep moving along here, Z height. I said I talked about this in a previous webinar, but I kind of wanted to bring it up again because it is a little trick that saves me a lot of time while I'm programming. So you have your blueprint, and you have a part that tells you different heights of different planes. So we have a plane here, we have a plane here, and we have a plane up here. So our blueprint has everything dimensioned from this top plane. This is datum A on our part. So what I'm going to do is I'm going to set up a system to be able to measure this, and if it's all we have is datum A and then datum B, there's nothing to skew to. So I'm just going to set my origin X and Y to the center point of datum B, and then I'm going to set a origin of Z to this top plane. To take tips from what I just explained to you guys of doing a system to get up and running as quick as possible, let's put that into practice. What can I fit in the camera window that I don't have to move my camera window around to get my part up and running? So I'm going to do a circle. I'm going to do an F-scan arc. I'm going to go boom, boom, boom. So I got a diameter here made up of this one little tiny little arc. I'm going to do a point of focus on that top surface. So now I can do an origin of X and Y to this, my circle that's made up of a tiny little arc, and I'm going to do an origin of Z to my focus point. Now, since I have an origin in the center of my diameter, I'm able to use the rotate function. So I'm going to do circle, F-scan arc. I'm going to do more inputs. And since I have a system, the next part that I run, I'm just going to have to do that one little arc and that focus point. So I'm going to come down here to my inputs. I'm going to right click, rotate. And I want to rotate this arc 90 degrees 3 times. So I already have one, so I need 3 copies. Click OK. I'm going to right click, remeasure that guy. So I didn't have to move the machine. And then now I'm going to come and I'm going to do my high mag plane on this surface. So I'm going to do a plane, more inputs, focus point. Let's call it a F-scan point. A focus point right here. I'm going to do the same thing, right click, rotate 90 degrees, 3 copies, right click, remeasure. Less work for me. Let the computer do the work for us. So now I'm going to reset my origin of X and Y to my circle, then my origin of Z to my plane, and now I'm good to go. I'm going to call this datum A and B. All right, so now I look at my blueprint, and my blueprint says the next level down that we need to measure a height is down about, not about, my blueprint says 0.472. So I come over a little bit to the side of my plane, so we're in focus. This is our 0 point now. Now I can move over, right click, move to absolute, down in Z, 472, and boom, now we're at the surface. I'm going to do plane, focus point, right click, rotate, 93. So I got that plane. So I'll do that again. I come over here, my blueprint says the next surface down. I right click, move to, I just look at my blueprint. It says, okay, the next surface down is 796. Boom, I'm right there. I do another plane. I do a focus point. I right click that focus point, rotate, 93. I got the other plane. And if I wanted to, the overall height of this part is 0.887 on my blueprint. So I'm going to come down, and that is the glass. So if I wanted to, I could put a little dry erase marker right here, or if your stage is dirty like mine, I can do a focus point off the glass, and then I'll be able to do a height from all of that. So we wrote that program pretty quick using the right click, move to absolute. Now let me explain all of that, what I did. I wanted to run through that really fast just to show you the speed of using it and how that helps you out. But when we right click and move to, the move absolute is off of your datum structure or your system. Since we set the origin of Z to that top plane, that means that top plane is now our 0 in our DRO. That's where the coordinate system is. So when we right click and move absolute, we're moving in relation to our system that we're in. So since the top plane is datum A, and I said that my 0 and my blueprint represents the same thing, I can punch in those numbers. We just got to be real careful, because if you're in the wrong system and you say move down negative 0.88 and your part is only, your part is say, 3 inches tall, you could crash into it. So just be real careful with that, using the move absolute. So you notice that I didn't right click and remeasure these. If I was just writing my program and just moving through the motions, I was just going to do that to get my program done. And so now I can do a distance from my top plane to this guy. And I'll go ahead and rename this dimension 1. I'm going to hit F3, or you can right click tolerances. And my Z height is supposed to be 0.472.